We've talked to our pilot, and he understands that we would like one that has a joint.
Sirius a little bit, maybe a meter or so, not much, but
piece
pretty
with a
stable.
node. We'll try very
that
hard.
Just be heaved too.
Yeah.
This is interesting. Okay.
Scott better come back from his dinner. He's gonna be sorry he missed this. I know he's listening to us.
Yeah, come up a bit. Can we zoom in partial? And hold there.
So Patty and I were interviewed last night by a reporter, freelance writer, and
So I think I might
she
just,
kept asking us about what have we seen that's new? What have we seen that's new? And it's like, well,
everything, practically.
Kind of hard to say everything, but you really
so much.
Yeah, they're all focusing on the fish, the Aphyonid that's now going to be synonymized with something else. Yeah, stand by.
You said you want a node, a branching.
Yeah, a branching
section.
Point if we can. Yeah.
How about that one just like
towards
10
the bottom
for lasers right now?
10 o'clock. Yes, that's fine.
Zoom tighter, Tara. Hold there.
But to the left of where the branch breaks off, right?
Yeah, just to the left. Yeah, to the.
Pieces. See if I can shove them in the bio box.
Okay.
All right. So scientists on shore, this piece that's a branching piece is pretty long, so it'll be kind of a challenge to put it into the bio box. You definitely need that branching piece, or will the if we get close-up video, would that be good enough? Okay, wait. Okay, so hold on, Dan.
Close-up video of it already.
Okay, so our expert on this says take the right-hand side below the branch point.
The right-hand side below. So
yeah, correct. That's what I was talking about when I mentioned it earlier on.
Is that what I understand? But you want the bottom of the branch point, right? Or at. Okay, that will make this a lot easier. Yeah. Okay. Okay. Yeah, I'm going to do it from this side then.
Okay, I'm going to go ahead and ramp up your hydraulics.
All right, guys, help me keep a close eye on everything.
All right.
You got it?
Yep.
Did you book? Sure.
Are you touching? Do you have a
I do not
toe?
have a hold.
Not at all.
No.
Okay. All right. Well, that's pretty good for not having a toe hold.
Yeah, I got auto depth and auto heading in.
You want me to take your camera, or are you good?
Yeah.
Yeah. Okay.
And help me keep because I'm going to drift a little bit, but I'm hoping I can do this relatively quick, so.
Okay.
Do you need any other cameras set up there?
Yeah, we could go for the mini Zeus. I guess that would help even though it doesn't have.
Oh, okay.
Okay.
Can't really get a good visual on it. But. Alright. All right. The nice thing is, even if I start to drift toward the wall, I can just bump us back.
That's it.
It'll be all right.
Looking good.
All right. Arms live. We do not have tilt, right?
Correct.
Of course. Is that enough, watch lead?
Yeah, I'm just trying to make sure that they want, they said something about the lower branch.
Oh, they.
Yeah, if not, that's fine.
Well,
You're fine where you are.
drifting away a bit here. Is that one I was going to go for? Is that okay? I mean, that'd be a lot easier here.
Yes.
Okay. Okay. I'm going to come back in a bit. Keep an eye on everything.
If you want to use that discrete movement again, like we did.
That requires auto XY.
Oh, okay.
Yeah.
You want some zoom in on that? Some video?
I'm drifting away here. Yeah. I have to come back in a bit. Is that okay? Okay.
Excellent. Okay, which side do you want to go for? Or you want to back out a little
I'm going
bit?
to back out first.
Okay,
Yeah.
all right, roger that.
Definitely.
We're ready to go,
Dan.
just decide which side.
Yep. Backing off the wall.
Okay.
You want to tilt me down a bit. And let's just go for the port bio
Port
box.
side.
Yeah,
Port
just
bio
easier.
box. Okay, roger that. All right, so extending the pin. And whenever you're ready, I'll open the drawer.
Yeah, you can go ahead.
Okay. Okay.
That is a long branch.
Let's see.
White against white. Yeah,
Kinda
no,
hard to
that's
see the
better,
white
Tara.
against the white, huh?
Got a little longer piece than I thought here. I think that'll go in.
Yeah, looks like it.
And
Perfect.
there it goes.
Okay, drawer
Oh, wow.
closed. Coming closed.
Yep.
So the combination of
Nice work, pilot.
the images that
Very nicely done. Okay.
Should be enough. Yeah. Mm-hmm.
All right.
Okay.
Hydraulics off.
Okay, hydraulics are ramped down.
Great, thank you.
Let's see.
And we're still looking just about 23, 24 meters off.
Yeah.
Yep.
Cool. Looking good. All right,
Okay.
let's continue.
Yep.
So help me keep an eye on everything. Never had this sample
Does that
free
look like-
floating before. Coming over.
Yeah, that's. It looks like we got a twist in the tether. there.
Great
Look at that.
job, Dan.
Is that the one we've been seeing on deck, I guess, huh?
Which one?
Say the.
The twist there?
Yeah.
Not sure.
Let's see. What do you. Oh, well.
Coming over.
Okay.
Full wide. Tara?
You're forward.
Okay, thanks. Coming up.
Okay. Yeah, it almost looks like D2 has to do a barrel roll to get that out of there.
Just gotta tip the hat.
That's it.
Nav.
Hey, are you calling me, Watchley?
There's a sponge.
Watch, did I just get a call from you?
No, we watch lead. This is pilot. We can
I
we
love
can ascend
sponges,
the
but
wall
maybe we
pretty
could
quickly.
hold off just so we can get up slope a little bit.
We
Is
can
that
ascend the
possible?
wall pretty
Yep,
quickly.
we're
We're
talking
25
to the
meters off.
pilot and the
We're
nav.
very comfortable, and I mean we can come up as fast as you want. We're just okay. All right, co-pilot. So I'm gonna have a constant ascent rate, and
Okay.
just follow me up.
Roger that.
Keep an eye on it.
Will do.
I'm just gonna push up until you tell me to stop and look at something.
So folks at home watching, what we're going to try to do is move up this wall a bit faster so that we're hoping to be able to see some outcrops of the ancient reef deposits that formed on the tops of some of these geos. So what our
about an
pilot
hour
and
left.
co-pilot are doing,
Hour and 10.
Okay.
the co-pilot is moving Sirius up vertically
So I'm
to
just
keep
probably
it
going
up
to
above
maintain
the
roughly
ROV,
this speed, co-pilot.
and the
Okay,
ROV
sounds
is going to
good.
be moving up a little bit quicker. This
It's
will give us a
comfortable
better
here,
view
Yeah,
over
everything
the
looks
surface
good.
as we
If
ascend.
anything, we're moving away from
And if we
the
see
wall
something
just a
totally
little bit.
fascinating,
Try to
we
catch
can
any
still
overhangs.
zoom
Yeah,
in
that's
and
why
take a
I'm
look. But we'd like to
I'm
get
like
to
3
the steep
meters off
part
here.
of the wall
I'm keeping an eye.
and
Yeah, but I
see
mean, on
if
Sirius,
we can
sonar
see some
there, we-
exposures
So I don't think we're
in
gonna
the
have overhangs that are
interior
25
of
meters
this,
off.
That would be
this
impressive.
flat top
We have to
ancient
explore that.
seamount.
All right, watch lead. Does this work for you? And you just let me know if you want to zoom on anything.
This is great, Dan. Thank you very much.
Okay. tall is this wall? Yeah.
I'm not really certain how to answer that, but it starts petering off at about 300 meters.
Okay.
It's awfully funny on high pack here.
How fast? You're coming up at 20 meters per minute?
I
So-
stopped for a moment. There,
Okay.
Something like that.
Okay.
I think that was a little too fast.
Yeah, so probably 15 is what. Probably
This is
15
really
meters per
tricky.
minute.
The you know, kind of flying off of this
Yeah,
this wall.
explain.
Yeah.
How the Sirius and the
It
ROV
must
are
be
rising
sloping
together.
away from us also,
Yeah.
And that
because we
also
are
means
moving.
that the tether
You know, it
to
is getting
Sirius
further
will be
away. So
spooling
And with the
in,
10-minute
point
down
delay,
in
maybe we should.
the winch room as we rise.
Well, I don't really
Let's
want to
get a little
play it
bit
safe.
further
Yeah,
away
yeah,
first.
I
We're
don't want to
seeing
push it
some
too close here.
fracturing
And then
in
just
the
do a
surface,
small
but
move,
the
5
Yeah,
surface
5
is-
meters.
still has
Yeah.
this
Roger
sort
that.
of
Yeah, we're coming
rubbly
up 300 meters
texture,
in this, at least.
and
Yeah.
completely
To the
covered
Sirius
with
scale.
dark
It's kind of like
manganese
blue water, only
oxide
you got a cliff in
coating.
front of you.
Yeah.
Oh, it's way more dangerous.
On
It's-
occasion,
and
we
way
see
more
these little
interesting.
Hard
ledges that
water.
have more sediment on
Hard
them.
blue water.
So 15 meters per minute. Cool. Okay.
Just 20 minutes or so.
Yeah, well, actually, so at this pace, we're going to be at the top of the wall in maybe just over 20 minutes or so. To give you an idea of our pace.
Thank you. Okay, so at this speed that we're going, we've been informed that we will be at the top
Yeah.
of this
Get
wall
a little,
in about 20 minutes.
Let's get a.
And we have an
Let's
hour
get a
and a
10-meter
half,
move.
about an hour and a half left in our
Okay.
dive.
080.
Okay.
Well, that should leave us some time when we do find some layers we're really interested in to perhaps do a little more sampling and get some close-ups.
Right, Chris.
Hey, ready for a
Agreed.
ship move. That's 10
Are you
meters,
seeing anything
0.80
to you
degrees,
that looks
0
like
decimal 1 knot.
layering in this material? I see a lot of fracturing, but I'm not sure I see layering. What do you think?
Good copy.
I have no
I think
clue.
you're good.
I'm not getting it unless.
Never mind. It's not that
I mean,
long.
is,
Doesn't matter.
are you certain we're in the interior of a seamount, or could this have
Yeah,
been an
but it's
old
not gonna
edge
make
of
any
a
difference in
terrace
a couple
ledge?
minutes.
Or
Maybe.
I just don't
1
understand
minute,
why
maybe.
we're not seeing what we saw the other day.
I don't either, Chris, to tell you the truth. I'm looking at the screen now, and maybe on the left side of what we're looking at,
Yeah, it's really
there may
sloping
be
off now.
some layering that looks as if it's dipping really, really slightly
Yeah,
Best we can.
down
you
to
don't
the
know.
left.
It's,
But
another
Exactly.
25
you know,
meters, it
the
could go
whole
vertical
surface
again.
of
Yep.
this wall looks all broken up.
Wow. That, that's it.
Yeah, and if it was just part of a terrace edge,
So
which
at
we
this-
were at
Nice.
yesterday,
Yeah.
we
You
would
can let me
see
come up to,
very
like, 10
heavy
meters
manganese
delta,
incrustation,
and I can have a little more
incrustation, I would imagine, and we're just not seeing that. So I guess we have to be in the interior of the seamount, but it's all volcanic so far.
Yes, certainly. I agree with you that we're in the interior. I agree also that the manganese coating here is
Yeah, it's
much
much more
less
comfortable.
thick.
Still got a good
So
view.
obviously this wall was exposed more
moving.
recently than what we were looking
When
at
you look at the
yesterday.
Sirius sonar, that looked
But
like a
as
buttress
we have
that
seen
we're on,
in
so
some
there
of
may be
the
flat wall off either
exposures,
direction
perhaps
there.
where things tumbling down the wall have knocked off the manganese, I'm seeing some angularity in the rocks that are
So you
exposed that
just called the
suggest
move
that
in
they
right now.
are
Yep.
igneous.
I'm,
Going off.
But
yeah,
also
meters 5.
seeing this
Yeah, we got 10
medium
meters
to
incoming.
sort of
And it's
dark
okay if I'm off the
brown
wall a bit
material that
because
looks
we're
like
just
it
doing a
has
profile,
fragments
right?
of broken
And we
volcanic
can't-
stuff in it.
We're not gonna
So not sure what
put
what
in
that
moves
came
without
from.
knowing.
What you got there?
I
what we
don't
got
see
in
any
front of us.
structures that look like the interiors of pillows.
There is-
Pillow lavas that would be exposed in the
So,
wall if this
I
were
don't know. It's
all
a
igneous.
sponge with a crinoid or something. I'm not
So
gonna stop
unless we
I hear
can,
anything.
find a
Yeah.
place where the manganese crust that
So
we're
we
seeing,
might have
although
some
it is
coming
kind of
back towards
thin,
you slightly.
isn't there,
Yeah,
it's
look at
really
the-
hard
round
to
egg.
Yep.
try to
Yep,
figure out what's
definitely.
underneath the
With,
surface of the crust.
Graffiti.
Yep.
So I painted it.
What about Deb, our Leg 1 science lead? What's your impression of the exposures that we're seeing on this wall? And the structures, too.
It's kind of cool. I'm going to lateral
So
over. Looks
exactly
like
as
it's
you
just
said, Patty, I tend to agree. I mean, I think that with these very
So
angular
that-
rocks
that's
that we're
like
seeing, we
one
saw
ridge
stuff
here.
that was like columnar jointing earlier. I think that we're probably looking at igneous rocks, although they are
That's what
still
we were seeing.
superposed in many crust, and it's hard to tell. And then the rocks that we saw that were
So that's what you're
sedimentary,
seeing
you know, it's hard to know whether those were volcaniclastic. Certainly the class looked like they might be, but
Yep.
Dean Renke, who's on our event log, you know, we were sort of bantering back and forth about whether these could be, you know, from some kind of reef material or whether they're some kind of volcaniclastic, and we just don't know.
I agree. What I did see in one of the outcrops where we had a lot of the brown material and a whole variety of smaller, angular, pebble to cobble sized fragments, many of the dark ones were very angular. They looked to me, just from the video, like broken up fragments of lava. But as we rise
I think
here,
there was a part also, though, Patty, when you were maybe when you were at lunch, where some of the class looked much more rounded, but still dark, and so it was a good question of what they might be.
I see.
It's definitely a first for me. I've
Yeah,
never seen
we
anything
are
like
we
this.
are looking
Oh, really?
at right now what appears
know
to
this
be
could fall
either an
underwater.
enormous block that has
Just
separated
a
from
sheer
this
cliff.
wall, or this
Gonna
is
see it on land,
a
but nothing
projection
like
of the wall that is
One of the most
more resistant to
Amazing
being
dives
broken
Shirley
up,
and I were on
and
was
therefore
off
has
the
remained
Bahamas,
intact
San
on the
Salvador,
side of the slope.
and there was
Not sure whether it's
3,000
connected
feet
to the
vertical,
slope, but we're getting to the
vertical
top of it
walls
here.
that just
Maybe we'll
went
be
like
able to
this,
see
in
if this
and
is
out,
a
and we just
knife
flew
edge
along it with the
ridge.
submarine.
There's
Big,
the top of that.
big sponges.
Okay,
coming
that
Look at that
is what it
crack.
looks
Amazing
like.
stuff, yeah.
This is a knife edge
What
ridge, and we can
happened
see a
there?
huge high angle
Can you brighten it up,
fracture
Tara?
in the rock surface
We can't really get too
that
much closer
extends
here right now.
above the edge of that block we were looking at.
We can maybe tilt
So
in a
this
bit.
whole area looks like it is just tremendously faulted. And there's a
So you should be
giant
headed
block
towards-
of
Are we
So you guys should be moving
We're
now.
moving now.
Yeah,
Okay.
we're moving.
a faulted
Cool.
stair step
That'll put
that
us 20
had sunk
25,
partway
27
down
meters
the
off.
wall that we're
That's good.
ascending, and that is to the north of the position we are in
That
right
looks like
now.
the abyss.
So the vehicle is heading for the ROV as we're looking at this slope is 83 degrees, so that's pretty close to due west. And we're looking at the flat surface of what must be a fault scarp. And it's a very high angle fault scarp.
So watch lead, as we move up, it's gonna, I guess we're getting,
We're getting close to the top here.
Not yet.
not really.
We got
I was just gonna say, like, we're moving up a lot faster than we want to move forward because we don't know what's above us, right?
yes,
So
of course.
I can't always stay right on the wall, but I'll do my best.
That's not a problem.
That's good.
So we're in a real comfortable position, and we got a 10-meter move coming in, so hopefully that'll bring us a little closer, but we don't want to do much more than that.
According to HiPAC, we still have 200 meters. We saw maybe a third of it.
Very impressive faults or fractures in the material that we're rising up along. On the left side of the screen, you can see this high angle fault that this block in the center is resting against, but you can also see a flat face facing us that suggests that there are orthogonal fractures. In other words, fractures at 90 degrees or close to it, to one another, just below the screen now. We see lots of crinoids on the sharp edge of the scarp. But there really are not a lot of benthic animals on this dive. It's
Nope.
kind of a surprise with
So what happens at
Such
the top
a,
of this wall there? It flattens out then? It's a flat
startling
top
Guess so,
outcrop
since it's
with
Not that
Side
many
to side
midwater.
face.
really
Not that
flat.
many midwater either.
pretty
So,
quickly
True.
too. Within 50 meters or so.
Okay.
It's pretty steady at 14 meters per minute.
Yeah, that's keeping us about 10. I'm varying it a little bit,
Look
but
at that face behind
Very
you, dude.
blocky
right
in
there.
the background.
wow.
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 Shirley, I don't see any indication of layering here, such as we had seen on the other interior of a faulted step in one of these
Yeah.
seamounts close to the trench.
So what does that tell us?
Good question.
Looks like the wall is moving back at the same pace.
That we're moving.
Yeah.
So
Well, that's
ROV,
good. That's a good
ROV
thing.
crew, you're getting compliments from our shore-based
Should be done moving forward here. in
shore-based
about 2
team.
Oh,
minutes.
let's get another 10 meter move in.
Okay.
They're saying, suppose it needs high techniques to keep the position that the ROV is keeping at such
We're-
a steep
Does that mean
wall.
both at the
Thanks
2
for the
knot, 2
effort.
knots?
We're
Or
doing
not?
our best.
Matter.
Yeah, we do 0.1. I mean,
Yeah,
it's really
amen
not
to
bad.
that. One thing, Patty, can we assume that because this is manganese crusted at least a little bit, that whatever caused this to happen was an earlier event than what caused the subducting GO1 escarpment to form?
Oh, yeah, absolutely. The fact that we've got manganese entirely encrusting these rocks suggests that this is an older event.
This is a delicate balance, isn't it?
It's kind of interesting because this particular GEO is further from the trench than the one that we were in, and yet it looks like this particular fracture occurred earlier than the other one. Or is that strange or isn't it strange? I'm trying to think through it.
Well, here's a thought for you. The bend in the plate is at its highest angle well below the overriding plate's edge. In other words, this plate bends so steeply that the 700-kilometer earthquakes lie sort of between the volcanic arc and the spreading center in the newly forming ocean basin to the west of the active islands. So this becomes a really steeply bending part of the plate. Maybe when it first begins to fracture, there may be a lot more movement, but because this fracturing process begins further out onto the Pacific
Might need more
plate,
moves here.
by the
Sirius
time
is losing the wall.
portions
Gone.
of the plate
Yeah,
that are
But there's not much we
nearing
can
the
do. I mean, we're going
trench
to play it safe, so
Yeah.
get
we're
closer
we're
to
gonna
the
have to wait
trench,
for
that
it.
most of the movement
We
is
have
already
10
taken
meters that
place.
we're waiting on moving.
Yeah, we're going to want to put
Not
in.
moved yet.
Let's put in another 10 meters.
Okay.
I mean, just go ahead and do it. I mean, is the ship still moving?
The ship is still moving, yes.
Look at that.
We have a
Yeah.
full 10 meters.
So
that's what we're waiting on.
On the screen right now, we have a dark, narrow band going from top to
Okay,
bottom,
I'm gonna
slightly
stop here for a while.
from
Yeah,
the
I'm
center
down
to
now.
slightly the right. And
Watch
it
the
has
pilot.
Hey,
columnar
can we just
jointing.
add on 10 meters
And
to the
it
end
looks
of that
to
one?
me like a dike.
Yeah,
A
so just so you know, we kind of hit
vertical
a
intrusion of magma
little bit of a shelf,
into
and the wall backs off
a,
quite a bit from where we are. But
into a
you know,
fracture.
I mean, we didn't
This
want
looks
to
igneous
push
to
the
me.
vehicles ahead without knowing what was above us. So we got 20 meters coming in. That should get us close to the wall in about 10 minutes. We'll start moving. So if we move up any more, we're going to lose the wall. So I'll just hang out here and look around for a bit.
You had told me when we were first looking at pictures of the site that this is part of a scissors fault. Is because of that, this is part of a scissors fault. Is because of that, could that partially explain what we're seeing too?
In a scissors fault, which is if you were to put your
I'm gonna come
palms
down to a pilot
together
and just
in
Okay.
a sort
kinda look
of
around here
praying
till we get
position,
caught up.
and then rotate, say, your right hand
Come down with you.
upward toward your face around
look
the
at what's here.
fingertips. Then you would see a steeper wall near your thumbs and a shallower wall near your fingertips. That's a scissors fault. And so normally
I'll come
what
back a
happens
bit.
is the greater
This is a straight
degree of movement takes place on the thumb side of the fault face. So there would just
That's
be
actually a good
less
question.
movement
Hey, watch
at
lead.
the fingertip side. So
So, I mean,
more
well, actually, this is a
movement
question. Do we want
and more
to...
continuous
We could
movement
continue up
takes place on
pretty
the steeper
quickly,
side,
and
the,
then
the
once
thumb
we get up
side
to,
of
you know,
a
about
fault
where the
such as
top
that.
of the
So
cliff is, we can
I'm
move
not
forward.
sure that
I don't
fact
know,
that we're
but
looking
we're
at
going to lose
the
visual on the wall
steeper
if we
and
do that. So that's
higher
okay?
side of the fault that we're diving on right now.
All right.
I don't see any reason why it shouldn't be more active. In other words,
Yeah.
shouldn't have less manganese. And yet it's completely covered. So, Chris, I don't know what's going on.
So we do not want to lose sight of the wall. Okay. Then we're definitely going to have to wait here then. Yeah. Okay.
Well,
Okay, so
we're only 10
yeah.
meters from the top.
Okay, so here's
Actually,
No,
No, we're not.
We're like
Oh, I'm sorry.
150
we're 150 meters from the
so-
top. So
I'm sorry,
here's
you're right.
here's what's happening right now. We hit kind of a ledge, not hit. We are at kind of a ledge. And so in order to stay close enough to the wall so that you can see any changes in the geology, we have to have this. The ship needs to move. Is that right? Am I explaining it right?
Yes. No.
Okay.
You're, no. I'm
Go ahead,
just-
you say it. Go
No,
ahead.
you're getting it exactly right.
Okay.
It's just a funny situation.
I
That's
know.
all.
So in order to be able to, just to see close enough so that we can tell if there's any kind of difference in the geology, we need to be able to move a little bit closer. But we can't move a little bit closer until the ship moves a little bit closer so we can
Yep.
safely move
And-
up the wall. So that's going
Right.
to take, how long did you say, Dan?
Well, it takes 10 minutes
minutes.
between when we call in the ship move and when Sirius starts to move.
Okay.
And then it's going to take another few minutes after that for the move to actually complete. So
Okay, so here's the choice. So we can either keep moving up and lose sight of the wall, or wait for the ship to move and continue to maintain sight of the wall so that
We
you
are
can
moving
tell
in a
if there are
little bit, so
differences
you
in
may
the
be able to
geology.
move up
Okay.
here
Did I
a
get
few
that,
feet.
Dan?
yes, that's
Okay.
exactly right, Shirley.
All right. So,
So, Chris, what do you want to do?
Chris and the rest of the team.
I'm pondering it right now. So we're 150 meters from the top. So I guess the actual feeder mouse display in the quad isn't quite accurate because it looks like we're still at the base and hasn't really moved a whole lot the
Well,
whole
actually,
time we've
on this
been
wall, I
climbing.
don't think our
Is that
sonar
correct, or
tracking
That's
is
correct.
going to be very accurate.
Chris-
misinterpreting what
Yeah.
I'm seeing in that nav display?
We're somewhere
Well,
around
let me
here.
explain. I'm seeing the ROV jumping around a bit in that display.
Coming up done.
And I think that we are further up the wall than where it is showing the ROV right now.
And I think
because-
you're going to want to see what we're looking at right now anyway. This is pretty cool.
Because we're at 4104 meters. And we do have,
And what's the depth of the top of the wall?
it's the top of the wall is at, I have
Yeah,
40,
what Derek told us this morning was
40.
4,020.
Stretched out, huh?
yeah.
But you're moving down.
Say again, I am moving.
I have
Yeah.
3960 roughly.
I'll just come up slowly and try
Yeah.
and keep sight of it. Then.
Okay.
It's 400.
And let's see, how much time do we have
Telemetry
left
might
in
be
the
off
dive?
by 100 meters. We have an hour, about a little over an hour left in the dive. Hour and about
this
an hour
is a
and
dike.
hour and 10 minutes or so.
Now, if you want to move me out to 80
We're
meters
seeing-
on
It seems like we have time to wait for the ship then, and in that case, is that correct, and still
Yeah.
possibly make it all the way up?
Yes, that's correct.
I think so, Chris. And what I'm looking at right now is an igneous dike. There's no question about it in my mind, which suggests that the rocks surrounding it may well also be igneous.
Okay.
'Cause how
All
would,
right.
if
That's
this
no,
were
it's no problem.
coral
no,
and
this is
reef
totally fine.
deposit,
It's totally fine.
there would have to have been
Hey, Pilot, do you
volcanism
want me to
at
move
the
you out on Sirius right now?
surface
sonar right
of the reef in order to get
Really?
dikes extending
this is
into
fine. I don't really want
fractures
to be
in the
further away
surrounding
than
reef
30
itself.
meters anyway.
I just
10
wanted to
10
see.
meters.
You can move me back to 50. I just wanted to see if we were
Can't
getting
really
a
tell
hard
how-
Well, maybe
turn.
this is a good opportunity to sort of do some close-ups so we can see anything to do some close-ups with as we're sort of waiting.
Yep. Okay.
Did you hear that, Pilot?
Sure did.
Okay.
Yep. So
Just zooms.
Zoom,
you want to go
zoom,
partial, Tara?
Zoom
See what we
on
can see.
Zoom on.
columnar jointing.
Zoom, zoom, zoom
for
back.
dike. Watch lead pilot.
Go ahead.
Okay, pilot, I wonder if we could just look at the upper left-hand corner
Sure.
a bit more closely. The lighter colored
You got it.
chunks just sort of resting on the shelf. I don't know, shall
You can zoom in further, Tara. Don, after this, we can continue up a bit, maybe.
Okay. Roger.
Okay,
How
we are
are we still
zooming.
feeling that move?
Yes.
I?
Yes.
Zooming to see
Should we
if we
get
can
another one in?
make
Yes.
anything out in the exposed
Yeah, I agree.
Let's go
vertical
ahead and do it then.
surface that can
Okay,
give us a
how far would
clue
you guys like?
as to the
I'm
geology
pulling
as to
you.
whether
Another
this
10?
is
Yeah.
Okay, yep.
What do you
reef
think, Dan?
material
I'm
or
on board
all
for 10.
igneous.
Yep, I'll do 10.
Certainly looks like a mixture of things to me.
All right.
Oh, there's a hey pilot on the
Bridge,
right-hand
nav.
side. What is this chunk that's
The
coming
right-hand
into
side.
view?
What is that?
Hey, we're gonna get another move. 10
Yeah, could we get a
meters,
closer
080,
zoom on this?
0.19.
This looks
I can
like
move in a bit,
Roger.
I think, here.
Thank
Am I
you,
going to pull you
pilot.
down?
Yeah.
About
No, I think
partial.
you got some
yeah,
tether,
this,
and I
this
can actually
chunk
come
that
down. if you
I
need
am
me to.
seeing here looks like a breccia.
Which
A
is?
breccia is a rock that is composed of coarse
And zoom in tighter.
grained material with angular
Hold there.
fragments.
You notice the camera
Semi-angular,
shaking
yeah,
when it
it looks
heaves?
like it's all cemented
Yes.
together.
Is that the
individual
backlash
pieces? You
on
can
the
see
camera,
a,
you think?
sort of a red piece in the middle and the bottom.
It could be.
There's
It
a
felt
gray
awfully,
piece
like,
over to the
Yeah,
right.
look at that.
I
I hadn't
kinda-
noticed that.
There's a
till you
big
mentioned
I
it.
kept
I
thinking maybe I was
piece
getting
on
like
the
a jolt
top.
from the tether, but the tether's loose. I think it might be the backlash in the motor.
Gotta check those
Thought it
bolts
felt
again.
kind of loose.
We have a variety of suggestions for how this forms, and one of them I thoroughly agree with. Fault gouge. In other words, broken up material along the edges of a fault as rock
looking down?
surfaces move against one
Should
another.
we start moving up?
Because
Hold on
the
a
surface
second,
of
I
a
wanna see
fault
what
is
the
not
sonar's
smooth
saying.
usually. It's kind of jagged,
Yeah, we
so
can.
it
Zoom out.
breaks the
let's
adjoining
start coming up
rocks
again.
We can start coming up.
along the
Oh, what?
fracture surface
Thanks,
into
Tara.
smaller pieces. And that could be either from a lot of the fractures we're seeing that are going into the wall or from the surface of the wall itself, which is likely a fracture surface.
So the base of this was like
So this material
For-
looks much finer.
1,300, right?
Oh, I
think that's
have it
what
right
I'm-
here. Let me see. Base of cliff. $4,325.
And
Okay.
this
And then
finer
the top of the
material with a
feature
few scattered
was what
cobbles
depth?
and
Or
boulders
roughly
on the
what
right-hand
depth?
side of the screen abuts directly
Wow,
against
this is
what looks like a dike feature. Pilot, can we get a zoom on the rocks to the left?
Yeah, sure.
Not sure how close we can get.
I can't get a whole lot closer, but we can zoom in. You
Okay.
wanna zoom, Tara?
Sure. Yep.
Honestly, I'm seeing the top around
Just
3970 or so.
Want to zoom
Maybe
sort of
slightly before
from
that,
the right to the left, if
3970.
you
Yeah.
can
So just over 300 meters.
kind of fan across,
Yeah.
or,
Sure.
or from here to the right.
From here to the right, you got
So
it.
did we get the zoom on the dike? Yeah.
Yeah, we're getting
Doing that right now. Okay.
Mhm. This is a dike. In other words, this is a high-angle intrusion of igneous material into a fracture. And as we get toward the edge, what we often see are fractures that are perpendicular to the edge of the contact. We're looking more or less at the face of it now, so it's hard to see those
Go
ahead.
those
Yeah.
perpendicular
That's about,
fractures.
that's full zoom.
Okay, that 20 meter moves over.
So we
It
don't
should
have a
be
lot of
close
lighting
to
quite
10
far
meters
away
still
from
coming
the
in.
surface.
How
But
much
it
more
does
do we have
gives
left to
us,
fuel on Sirius?
10 meters.
does give us a good
That's good.
sense for the structure of
Let's
this
get another 20 in. I mean,
Okay.
vertical or near vertical feature.
I just changed it to the 80-meter scale there, see.
Yep, starting to be covered up with
catch
sediment
that.
on
Oh,
its
man, we might-
surface now. So I think that it's angled not directly
So we
into the
have-
slope,
It is
but
definitely
angled
changing.
slightly
What was the
into
top
the
of it,
slope
39?
and to the right.
I'm seeing it 39.70. I mean, it's up here.
it could be offset from USBL.
Could be.
I mean, we might be near the top here.
So we got a 10-meter move.
We got a
that's
10.
just
Let's
coming in
get
for the
another.
end.
Let's get a.
Okay, so
20.
for those of you
20,
who are
yeah,
watching
call it
from
in.
home,
20
we are
meters
waiting
down.
for the ship to finish its movement so we can continue our
I think you're
ascent
moving,
up
Don,
this
right? 'Cause
wall.
we got some slack.
Yeah,
You're able to
yes,
see
we are moving.
the
I can't
view
tell
of
how
this
much,
wall
though.
that we're on from the video from the Deep Discover
Hey, can we go ahead and
ROV.
get
You
a
can also
20
look
meter?
at
That's
screen
20
2 and
meters,
see a view from the
080,
Sirius down to the Deep
0.19.
Discover. And I believe on your third screen you can see what we call a quad screen. So it shows you in the upper left what we're seeing from the Deep Discover, and then you can
I mean,
see
if
where
the
we are in
picture is
terms
saying
of
we
our
were near
dive
the
track
top, I
on the
just put on
lower
like a
left.
30
In the
meter
upper
move
right,
or
you
more,
can
but
see
I'm almost
what
thinking we're changing direction,
what screen
too,
the
a
pilot
little
is
bit.
Yeah. I've been
looking
kinda
at, and the
following that
lower right
ridge,
you can
yeah.
see the sonar
Right, which is more like
returns
a 50
from
or
the
60
Deep Discover,
degree
which is the one
Yeah.
on the
heading
sonar
than the 80.
returns on the
Yeah,
left,
let's
and
keep
from
coming
the
up a bit,
Sirius,
move
which is the one
slowly.
you're seeing on the right.
If we lose the wall, then we'll.
We are coming to you
I mean,
live
you're 30 meters in front of
from
you can
the
range out my
NOAA
sonar, yeah.
ship
Okay.
Okeanos
Yeah, you're
30
Explorer,
meters.
America's ship
Right
for
now,
ocean
50.
exploration.
Yeah.
And we are looking at what appears to
Yeah.
I don't think
be
I have control. Okay, there it goes.
nearly vertical wall in front of us
There we go. Found it.
that looks as if it's made of very fine
so that's looking
but
at
cemented, well, much finer material that's cemented.
looking at right at 15 meters
This has been
from you.
an
Yep.
It's like
unexpected
45 meters from Sirius.
exposure of rock.
Gene Ranke says it
hold
looks
on,
like
don't let me catch
modern
up that
sediment
much.
to the right, not material that was intruded. I think that was
To the-
entered
to the right,
just a few
yeah.
minutes ago.
Yeah, I agree.
About 2 minutes
I agree
ago.
with that. I think it was material
Okay, so you
that
called
had
in the
fallen
20?
down
Called in the 20.
pretty
So
recently.
we have like
that
25
covered the
meters
surface.
Yeah.
coming up.
Yeah.
I don't want to like
Actually,
start rushing into that and then have something pop up on us. You
We
know?
are coming to you live from a feature
Oh,
that
look
is
out
called
there.
Subducting GEO 2
Can't even see anything.
in
It's gotta
the
be
Mariana
at least
Trench
6,
National Marine
you know,
Monument.
20
Yeah.
meters out.
And we are on dive 20 in 20 days.
Of 22 that we will complete on
Right,
this mission.
that's right.
Okay,
We have
so
2
let's-
more
let's do
dives
the math
after
here and make
this.
sure.
Yeah, I'm checking right now because you got 45
This
meters
is
out, right?
part of
We
the
have 45 meters to
2016
go.
exploration
20 meters in
of
about
the Marianas Trench National Monument.
11 minutes.
11 minutes.
So-
we'll be 25 meters off the wall.
So about 9 minutes.
Okay.
9 minutes from now.
All right, watch lead. This is pilot. Yeah, we with our current ship moves, we're going to be 25 meters off the wall, which is very comfortable for us, and that's going to be in about 9 to 10 minutes. I mean, sorry, I can't get you a better view here, but it's kind of the game we're playing right now. Okay.
Okay, so we'll be about 10 more minutes, and then we'll be able to get a little bit closer to the wall.
And that'll be on that point to your port there.
Okay.
This deepwater exploration of the Marianas expedition is made possible through partnerships both within NOAA, the National Oceanic and Atmospheric Administration,
Right, tilt your camera
their
down a bit,
Office of
though.
Ocean Exploration and Research.
Just trying to get an
Ships
image on the
operated by
sonar.
NOAA's Office of Marine and Aviation Operations. The ROV is operated by
yeah,
another
120 now.
partner,
Yeah,
the
I
Global
went out to
Foundation for
120
Ocean
looking for
Exploration.
something.
And you've heard from our
Well, that
pilots,
thing,
a little
it's not
ROV crew and
So it's far away
videographers
anyway.
a little
Yeah.
while ago.
Well, 80, 70 is probably
And the
about
expedition
this
is,
one, fifth,
actually, let me
150.
name another
Okay.
Seven
couple
is
more
probably the
partners
max
from
of
NOAA.
what we're actually going to
National Marine Fisheries Service,
Okay, I'll leave
the
it
Marine
out.
National Monuments Program, the Deep Sea Coral Research and Technology Program, and the National Center for Environmental Information. That makes 4, not a couple.
Down a bit, just
Okay.
This is all part of a campaign called Capstone. campaign to address the Pacific Monument science, technology, and ocean needs. And Capstone was designed to address the needs of our marine monument resource managers to better understand the deepest parts of our nation's marine monuments. The partnership that we have with NOAA's National Center for Environmental Information is making it possible for all of the data that we collect, so the images, the data, to be made publicly available within 2 to 3 months after they're collected. This is extremely fast for data to be made available to the scientific community and to the public. Typical timeline is closer to 2 or 3 years on many of the expeditions that Patty and I and our shore-based science team are used to, where we have an expedition that involves many scientists on one ship, maybe as many as, well, on some of the drilling ships it's a lot, but on some of the ones that I've been more used to, it's probably about fewer than 20 on a ship. And then we have pretty much exclusive access to the data and the samples until we publish on it. So it's about two years or so. But for these expeditions, we are doing these on behalf of the entire science and resource management community. So it's really important to have the data and the samples available for analysis so we can take action on the interpretation of those data, especially if they impact management of these resources.
There's nothing on Sirius sonar, you know?
The samples that we collect, so far today we've collected 1 rock and 1 organism. The rock samples are going to go to Oregon State University, and they have a repository there, and samples will be logged in there.
I mean, even if he's, so I'm
if you're
30,
interested in
I'm
working on these
25
samples,
meters ahead of him,
can,
and I
go
am
to the
10 meters off the
Oregon
wall.
State University,
So
I
it's
think it's the
35.
geology
We have 35
website,
meters
and there's
from Sirius
a protocol for
to the wall.
requesting access to those samples. Similarly, the biological samples are going to the Smithsonian Institution in Washington, and
we're also
again,
coming
once
up
those
at
samples
15 meters a
get
minute.
entered into their collections, they'll be
And,
on a
I mean, we
database,
still have,
and samples can be requested
so you said 39 something for the
study.
top of the wall, roughly.
And for most of the biological samples that we've
3960. So we have about
collected,
100 meters to come up.
we
We
are
could be up top
preserving
of
a
that.
small piece, a
3
subsample
minutes,
as we
right?
call it, and they're being preserved
I
in
mean, if we
special
really had to.
buffers or solutions to preserve the
Let's just-
nucleic acid, so
Let's just call it in.
we can get molecular data. And those samples are going to the Ocean Genome Legacy
Did you
at
catch that, Don?
Northeastern University.
Another move. 20
Those samples
meters,
will be
080,
analyzed, and the
0.19.
data will be made, again, publicly available, and the samples can also be requested for further analysis.
We're moving in. We've got 40 meters in, or 35 meters incoming.
So the way we operate is
We've got 100 meters to go to the
fairly
top.
unique.
So even if we,
As I mentioned,
you know,
our
we can get up
operations
to
are
the top of
driven
this
by the
in
science and resource
3 minutes
management community,
if we really need
and
to,
they're
which we
carried out on
shouldn't have
behalf
to.
of that community.
But
And
I
through
think we're safe to start
telepresence,
coming up
the technology that makes you at home able to see and hear what we're doing in near
there's
real
nothing on
time.
Sirius sonar, so
We're
I
able
mean,
to have dozens of scientists
it's smart to
engaged
put
in
in
an
some moves to
expedition,
make
more
sure you
than
see
we
the
could ever
wall.
fit on the types of expeditions that Patty
You're
and
coming
I
up
and our
now?
Yeah, I'm coming up
shore-based
slowly,
team are
real
used
slowly.
to having. So our scientists on shore are participating from Exploration Command Centers, or ECCs, that are very similar. They're kind of replicas of what Patty and I are sitting in right now. Or depending on what time it is, where they're joining us from, they're maybe sitting at home or in their offices participating. And today we have participating Asako Matsumoto from the Chiba Institute of Technology in Japan, Chris Kelly from the University of Hawaii,
Can you gain up, Tara?
Debbie
No, it's not going to
Blaney
look
from
good,
NOAA's
but
Office of Ocean Exploration and
on
Research,
D2.
Deb Glickson from Harbor Branch Oceanographic, Florida Atlantic University, and along with Diva Aman from the University of Hawaii, who's also participating. The two of them were the science leads on leg one of this
And you're moving
expedition.
down, so
We have Gene Ranke from the University of Kansas. We have Les Watling from the University of Hawaii. We have Scott France from the University of Louisiana. Tara Luke from Stockton University in New Jersey. Tim Shank from
kinda
Woods Hole
see it up.
Oceanographic
Yeah, right here.
Institution, and Tina Molodtsova from the P.P. Shirshov Institute
That's,
of Oceanology in Moscow. quite a diverse group. We
And
are
I mean,
really
that-
all
As
over
we
the
come up, it's
world.
going to slope further.
Lots
yeah.
of different time zones.
Yep.
So we're safe.
And they are our
Swing out here for a
shore-based
bit while you move
team.
in.
So that's what makes it
I'm gonna
really
zoom in.
amazing.
Off in the distance
so
there.
that scientists can participate in all of the dives and some of the dives, and the dives they're particularly interested in and have expertise
Yeah,
in.
sure.
So
And now we're looking for fish.
Some kind of.
Well, we are in midwater, folks. The reason that we're not seeing anything of the bottom at the moment is just that the ROV and the Sirius vehicle are moving up in the water column, and because the slope is so steep, we have to be very careful not to encounter overhangs, that sort of thing. So the pilots have asked the navigator to get the ship and the Sirius and the ROV in position so that they can rise safely, and we will be back on the bottom
Yeah, I've
shortly.
lost it.
Yeah, I can see it. I can
These
see it.
kinds of
See the
moves
bottom,
take about 10
Yeah.
minutes from beginning to
Plus
end.
Yeah,
sonar.
sonar's
Yeah,
gone.
yeah.
Yeah.
So on board here, in addition to the ROV team and videographers, and of course our most awesome ship's crew, who
Yes.
making this appear like
Yeah.
so
it's
seamless,
just
like
done
nothing.
every day.
Right. I was telling CO this morning, no drama.
Yep. No,
Really
really,
awesome.
Indeed.
And in addition to that, we have our mapping team. If you were in on our pre-dive call, you heard from the head of our mapping team, Derek Sowers, and every day after the ROVs are brought up on deck, they begin the night watch. So they start mapping, getting some higher
back on here
resolution
somewhere there.
multi-beam maps
Yeah,
of
Sirius
the
is
bottom,
moving
so
and
we
creeping
can more
closer.
precisely
At 30
plan our
meters.
dive for the
Yeah,
next
I've
day.
stopped.
In addition to the
Coming up
bathymetry
soon.
data, though, they also collect information from midwater, so we can see if there are reflectors in the midwater that sound sources bounce off of, so layers of fish. We also can see, when we're doing surveys, the sub-bottom. In other words,
zoom in on
there's
that?
Down a bit,
It might be
an
like
acoustic
yeah.
measure of
Okay.
how thick the
Just easy
sediment
bias
is on the
drifting down.
seafloor.
Yeah,
So that helps us to interpret
Okay, that
structures
20 meter
on the
move should be
seafloor geology
finishing up
and so forth.
On Sirius.
And then
on Sirius.
they process
We
all
got
of that
20
data.
more meters
They
incoming,
process
right?
it
Yeah,
as
20
they're
more meters
going along.
incoming.
So there's a tremendous amount of work that goes into, sort of miraculously to some of us,
We can do another one.
the construction of these beautiful bathymetry maps that we base our
I can give you
dives
some
on.
more,
So
tether.
the guys are
You wanna
working
just-
hard overnight.
Push further out.
Yeah, I'm pushing out.
Yeah. Okay. I'm coming down.
In your quad screen, which is on the third feed that you have over on the right-hand side among those that are right below the
Yeah,
video
that's-
screen,
Okay.
there are 4 images. In the lower right-hand quadrant of the quad screen, you will see 2 circles.
Once more.
The
Pilot.
circle on the left-hand side is this
We got the
sonar
wall.
image
There we are.
being detected from
I think with 20 more
the
meters, I
D2
should be able to get back
and the
on it.
bright
Here. Let's.
green and orange and yellow.
What's the time since you called in the last one?
returns that you're seeing are
6
from
minutes.
the wall,
It's moving right now.
and
Sirius
the
is on the
range
move.
for that
Okay. Let's
circle,
call in.
all those lines, total
Should we do another
of
10?
meters.
Yep.
10 or 15 up
So
there.
the
Let's do
wall is
15.
about
That's good.
7.5 meters in front of us. So we'll be seeing it again shortly.
Carl.
And I just wanted to finish up,
Bridge now.
because I didn't forget him. I just want to finish up with one more person who's been
Hey, let's throw on a 1
in the
5 meter
in the
move. 080,
background, not on
0.19
any of these,
in
usually on any of these calls, and that's Matt Dornbeck. And Matt has been
And
working.
where is Matt from?
Matt is, and I've been saying mentioning his affiliation incorrectly, so mea culpa, Sharon Misek. I've been saying that Matt is from Deep Sea Coral Research and Technology Program, which is contributing to sponsorship of this cruise. But Matt is actually from the National Center for Environmental Information, and he works for my friend and colleague Sharon Misek. And Sharon, in case you're listening, he's doing a most awesome job as well. We are so glad to have Matt out here, in addition to keeping us all straight on management of these data that we're collecting, I think Patty and I would be at a
We'd be
loss
lost without him.
because he's helping us
been
every
great.
single day with processing the samples, generating the labels, making sure all the data are entered properly. He's
And
been awesome.
when we found that a lot of the bags had leaked and the labels had, whoa, Nellie, the effort that Matt put in to reorganize things when there was some difficulty early in the cruise that we discovered with previously collected materials was awesome. Thank you, Matt. So we are beginning to see the seafloor coming into view, and surely there is a big sponge down at the bottom of the field.
Okay, well, let's stay focused.
Yes, yes, stay focused on getting there. It looks like we are still seeing a lot of sediment covering the wall at this elevation, which is, we are at, the ROVs at 4,056 meters.
The
but
dike
it
is back in view.
14 meters off the bottom.
I think I'm tugging you down. I'll back up a bit.
Okay.
Yeah, I'm not
Well, I can
so
come down a
sure
little bit
that
again.
the dike is
Sure.
what we're looking at.
Pretty
It's
much
not
with a few
quite as
minutes break in
coherent as it
between.
was a little bit lower down, but there certainly are some
Like,
individual
Not continuously, because I mean it was
vertical outcroppings of harder material surrounded by loose sediment on the rock face in front of us.
We
Or
finally
the
have the
face
reading
of
in
the wall, I
Sirius there.
should say.
Yeah, right. Yeah, but it still appears like a sloping surface, not a hard vertical, you know.
Kind of does look like that, yeah. Well,
But
Part of
we'll
it.
see.
maybe we're at the top. Maybe this thing is just throwing off our use.
Okay, this is rather curious, says Gene Ranke. If the wall is vertical, how is there sediment? The angle of repose is not vertical. Agreed, there is some, but yeah, sloping does sound correct.
Yeah, there's a lot
how
of
much
terracing
move left
in
for
this,
Sirius to
this
feel?
wall, and
about 18
I
meters.
have
18
seen
meters for Sirius to move. Okay.
some
we
sedimentary
can, come up a
material
bit down.
draping portions of the
Push
slope
out and-
that are a little shallower, and the sediment
Come up slowly.
You're going to come up as well.
basically
Yep.
makes
Okay.
triangular radiating paths
They wanna-
as it falls down the slope in front of us. So obviously it can cling. Outcropping material on this wall is going to collect sediment in little patches. So if our short baseline nav is correct, the position of the ROV on the bathymetry screen.
Are you talking to Nav?
No,
Oh,
I'm
okay.
talking
Oh.
to folks at home
Oh, okay, sorry.
who may be looking at the quad screen. The lower left part of the quad screen shows a bathymetry map with curving lines that represent equal depths. Equal depth points are connected to make these curves.
Looks quite
and
steep,
the
huh?
ROV
Yeah.
seems to be jumping around. It's not actually doing that, of
Yes,
course,
yes.
but it's our navigation to the remotely operated vehicle. So the ROV is being navigated
Nav, this is Survey
by
1.
a short baseline system.
We're gonna need
looking
more
at,
meters.
pingers
Hey,
on
would
the
you mind
vessel.
drawing me a line to see from
because the
the
vessel is
location where you guys
elongate,
landed to where you are now?
It
How
does
far
appear
you've
like
covered, please?
the ROV is jumping
yeah,
from one side to the
Thank
other.
you.
It's just that you
Not
can't
draw-
resolve
You want,
the position
five-
unless you have
That's
3
right.
points.
It's not drawn to scale.
So
Well, it's
how
also
much
not drawn
left?
to scale,
Right.
but,
Oh, we got-
but it
Actually, we got
it
about
may look
10
like
meters
it's
still,
bouncing
12
from
meters.
side to side beneath the ship. And
Yeah.
But
Let's
it's
do
really not.
another-
Yeah, it's really not.
20, 25.
20. I'm thinking let's just do a full 30.
30.
Okay, I'll do 30.
Well, this
Survey
wall
1,
certainly
this is where
is
we
interesting and surprising.
Yeah, I mean,
And
the top of it is in.
To tell you the truth, the whole
70
thing
meters.
looks a lot more
Survey?
igneous than I would have suspected.
Did you catch that?
I did. Sorry, I was on mute. Thank you very much. I appreciate it.
And we have a
Bridge
floater.
nav.
What is this, Shirley? Is this just
Not
goo?
sure. Just yeah, it's probably just goo.